joining us here. My name is Shai Tsur. I'm with ARM, out of the San Jose office. I'm with the infrastructure group inside ARM, responsible for the software ecosystem around the work that we're doing with NFV, among which I am also the business development lead on the work that we do around universal CPE. So I wanted to discuss today kind of the work that we're doing in UCPE and kind of some of the directions that we're seeing for the development of the platform. So if you hit, okay, there we go. So actually, can you click one back? Sorry, I missed this jumped forward too. There we go. So actually wanted to, for those of you who don't know ARM, and I'm always kind of surprised that people kind of know the name generally, but aren't 100% familiar with the company. So ARM, I like to say, is the most important tech company that most people haven't heard of. You know, most, and to the degree that people have heard, they know us from the mobile chips. We're the vast majority of mobile devices today run the ARM architecture. But ARM's really an ecosystem company. So we design device IP for processors, and other companies take the IP that we design and then build those into chips and SoCs. So we have a history in extreme power efficiency and computational efficiency that we've taken well beyond the mobile handset market and the embedded market, and have taken it throughout the ecosystem. Next slide. Great, thanks. So today, ARM is really everywhere. So we're the only architecture that spans everything from very small IoT devices up to and including, cloud data center, telco equipment, telco core, basebands, IoT gateways, really kind of the whole span of the network from small to large, which puts us in a unique position to see how the world is changing. And over the last 10 years, we've really seen a shift in the way the network has changed, where data is increasingly flowing less from, say, the cloud data centers to the devices, which had been the paradigm up till now, and really kind of from the devices the other way around, where a lot of processing is going to be done at the edge. And as far as these kind of edge use cases, we see universal CPE as being one of these. So let me see if this is working now. Still on. Can I get the next slide, please? Sorry, next slide, please. Thank you. So ARM has a number of unique capabilities, given our history and what we do, that allows us to provide really efficient solutions for edge devices. One of which is the scalability and the heterogeneity of our ecosystem. So as I mentioned, we have a large number of licensees that take the ARM IP and build it out into different solutions. So really, like I said, you have, because of the mesh network that we provide, these SoCs can fit most every use cases by adding different subsystems, memory controllers, acceleration, etc. Next slide, please. And when we talk about acceleration, this is one of the things that differentiates a lot of our partners, where given the SoCs, they're able to take some of the workloads and offload them from the CPU to the SoC. So for the purposes of the universal CPE, the important ones are some of the TCP/IP offloads that we see, and some of the crypto and IPsec acceleration that we see. So for instance, one of our software partners, Telco Systems, recently did some work with an NXP LS2088A platform, where they utilized NXP's AIOP networking processing offload, which actually takes the virtual switching off the main CPU and integrates that with OVS. So essentially what you're doing is taking the OVS and offloading it from the CPU, and in that way they're showing workloads with something like 5x performance compared to having the switching on the chip. Next slide, please. And the third kind of key to success at the edge in UCPE is security. So Our IP is really built with security in mind. It's built with security from the ground up. And we do this in two forms. There's something we call PSA, or Platform Secure Architecture, which is a framework for designing systems, which was originally built for IoT systems, but we're now moving it out for a PSA for the edge as well, that provides the system builders with a set of guides of how to build device level security. And this is combined with ARM Trust Zone. So ARM Trust Zone allows you to do on-chip encryption. So essentially you have a secure environment and a non-secure environment on the same CPU. And in that secure environment, you can store keys that can be then used to do things like hardware root of trust, which can then be used for things like secure boot. Next slide, please. So that's the whole idea of scalability, multi-CPUs, acceleration, is really the development of where we are with the ARM-based universal CPEs. And it was actually here at the SDN NFV Congress 2 years ago that we first showed off an ARM-based universal CPE device. This has been the product of work that we've done through a partnership with Telco Systems as the NFVI and orchestration layer for these devices. And we've worked with them and a number of our chip partners to provide boxes, ARM-based boxes, 4-core and 8-core boxes, with a range of VNFs. So we have a growing VNF ecosystem that today includes things like 6WIN for routing, Clavister for firewall, FatPipe for SD-WAN, and it's kind of growing beyond those as well. And so we have a number of small-scale solutions that have been very attractive to operators looking for devices that are very kind of cost-effective. Next slide, please. And one thing I can call out now is another, one of our partners actually in the room is Ampere Systems. Ampere Systems has the eMAG platform, which now allows us to provide ARM-based universal CPEs with greater capabilities. So if we were up to kind of 4 or 8 cores before, now we can scale that out to 32 cores as well. So if we were looking at kind of maybe SMB type boxes, this really scales up to full enterprise universal CPEs. So we really have a range of platforms available today for the deployment of universal CPE devices. Next, please, next slide. And why are we seeing so much interest in ARM-based devices? And it really comes down to the idea of TCO. So with the operators, the TCO justification is basically based on a combination of the cost of the hardware and the number of VNFs that you can be running on that hardware. And this becomes key when you're looking to deploy services in emerging markets that are a lot more, let's say, price sensitive for the cost of the hardware. So you really need to know that for a lower cost solution, you can deploy a service that can run multiple VNFs on that box. Because if you're only kind of replacing bare metal devices with single VNFs, the cost justification doesn't make sense. Also, the security here is key, and this is generally applicable not just for the smaller scale devices, but in general, that when you have these devices that are off your premises, when you lose that kind of that physical security that you would be able to provide when you're running services from your premises, you really need to know that there is on-device security that can keep these devices locked down. Next, please. So on the TCO front, the advantages that ARM shows is a combination of both the fact that we have devices that have multiple cores or many core devices, and what I was talking about with the acceleration earlier. So if you're looking at kind of a very general calculation, for the same dollar-to-dollar price, a 4-core x86 system, for the price of an x86 system, you can get an 8-core ARM-based system. And of those 8 cores, you can, if you're looking of the cores in the CPE system, the NFVI itself monopolizes a full core. The OVS DPDK tends to monopolize another core, which leaves you 1 or 2 cores to run the VNFs on. And that's usually enough to run one. With an 8-core ARM-based device, you can offload the OVS, and now you've got 7 cores free, and now you're talking about running 3 VNFs on that same device for the same price. So the TCO advantages are very clear. Next, please. And then you combine it with what we said, the ARM trust zone for providing keys in the trusted environment that can then be used to enable a root of trust, and that every stage in, say, the boot process can refer back to that key to make sure that everything's secured. You can also use this same procedure for managing various VNFs on a device. So if you have multiple VNFs from different vendors, using that same hardware root of trust, you can ensure that they're not able to mess with each other. Okay, next. So this is kind of where we are today. And like I said, we have multiple platforms available. We have an ecosystem of VNFs, and we're starting to work towards deployments with operators. And now we're looking towards the future. And if I had to kind of like sum up the future in one word, it would be containers. And I think that's been mentioned a lot at this conference. So, VNFs have been if we look at the evolution of this industry from single-purpose devices, the VNFs was a stepping stone. So, I mean, with the transition to VNFs, you get flexibility, which is the key point, but you don't necessarily get full optimization in terms of power consumption and latency and things like that. Not to mention the problems that you have with portability, with kind of porting VNFs from device to device. And here, when we talk to the major carriers, they believe that containers are going to be the key to solving these problems. In addition, there's a belief that Kubernetes might be the end game of the great orchestration wars, that this will be the way everything gets orchestrated. UCP is going to be part of the revolution as we move containerized applications down to the edge. Next slide. So just to kind of throw some numbers out, if we're looking at a transition from virtual from VMs to containers, you can see that the size of the applications drops dramatically. The start time is in milliseconds rather than minutes. You can spin these things up and down very easily. And you're able to kind of utilize many CNFs per core versus one VNF. So next slide. So take a second now just to kind of call out some of the things that the team I work with has been doing in terms of expanding the container ecosystem, or the cloud native ecosystem, as it were. We've recently made a couple of partner announcements, one of which is a partnership that we've done with Docker, where Docker Desktop now enables developers to deploy containers to ARM-based devices natively. So from the same Docker Desktop that they use to write containers to an x86 platform, they can now deploy those onto ARM-based devices as well. And this has actually been combined with the work that we've done with Amazon that has ARM-based EC2 instances, so you can deploy your containers to AWS, ARM-based containers to AWS. Next. And then we've also recently announced the conclusion of work with Rancher on the K3s Kubernetes platform. So this is a very low footprint Kubernetes distro whose binaries are now available to run ARM64 and ARM v7 based containerized environments. So we really have the ecosystem of partners working with us to ensure that the container ecosystem is ARM ready and ARM friendly. Next, please. So the other kind of step towards the future is really this idea of microservices. So I mean, the container is one piece of it. The other piece, of course, is decomposing these applications into different microservices that can be spun up and down a lot more efficiently. And this is actually kind of a revolution in and of itself, because if we look at the migration that we've seen in NFV from appliances to VNFs, the application itself hasn't really been broken up. I mean, it's really more a matter of running it virtualized rather than doing anything onto the application. This is really going to be an interesting step to see how the ISVs are going to tackle this challenge. Next slide. So that kind of brings me to this, let's call it a reality check here about containers. So, I've heard a couple of people in this conference saying that, that VNFs are the thing of the past and containers are the present, which kind of gives me pause because, I think, VNFs are maybe the present. They're just getting to be the present, really kind of early adoption. Especially when you consider that the shift to VNFs has been pretty painful from the ISV perspective, giving up the kind of the business model that they've had and doing the relatively easy work of taking these appliances and running them virtually. This has actually come with a lot of pushback from the ISVs, and it's really kind of the end customers that are deciding that has to be done. So it'll be interesting to see, now that there's an engineering effort that's pretty much an order of magnitude greater than what we've seen with the transition to NFV, how they'll handle that. I think what we're seeing today is that the CNF usage, such as it is more business case driven. So I think the ones that we often see right now are testing services such as Ixia and Spirent, which makes sense to be containerized because really what you want in a lot of these cases is to do kind of a health check on the device. You want to spin up a testing solution, do the check, and spin it back down. So this will really be a matter of finding those business cases where the move to containerization and microservices makes sense. And I think a lot of it's going to come from from really the end user needs as well. So if you're running a smart retail environment or industrial IoT environment, you're most likely going to have functions that you're going to want to containerize and run on universal CPE devices. What this means, however, is that at least for the foreseeable future, I think there's going to be a need for both VNFs and CNFs to coexist, and we'll need hybrid environments that are capable of running both. Next slide, please. And this is actually a demo, again, that our friends at Telco Systems have put together, showing what one of these hybrid environments would look like working with their NFV time infrastructure. So you have, in essence, a VNF, in this case a 6-wind router, coexisting with a containerized firewall, and the one system has the ability to provision both kinds of services and service chain between the two of them. So, we really believe that, for the transition period, it's going to be devices that look like this. So one last slide. Okay, and so when we talk about, just kind of to summarize, I think when we're looking at the future of universal CPE devices, it's going to be about multiple core devices. So multiple cores that can take full advantage of device acceleration, that can best utilize containerized microservices with a strong level of security. And with that, I have a minute and a half left if anybody has questions. Anybody? Here, hold on.
I don't know if it's true or false, but discussing after that there are some dependencies between the VNF and the processors that are running on, and that essentially, for example, VNF being written to run on x86 architecture, and it's not straightforward potentially to have them run on ARM. What is your point perspective on that?
No, there is a porting effort to be done to run on ARM-based processing. And actually, we believe that the containerization is going to make the portability issue also a lot easier. I've always been surprised by how relatively easy it has been to port applications from x86 to ARM, and it's really been more kind of getting the ISV buy-in to do it, and just making sure that there is a business case for it. Other questions?
Actually, I have a
follow-up?
Yeah, I have a second question, which is about security. You make security as a big point, and,
yes.
And actually you talk about that. So what's your perspective about security and moving to containers? because there are some
Yeah.
discussion about their VMs provide isolation, containers less.
So this is one of the kind of great unsolved questions of the container world. What we've seen right now, the kind of the best solution, which always strikes me as odd, but it is what it is actually running the containers in a VM and using the VM security for that. It's one of these challenges that's going to have to be sort of tackled in the future to kind of get more container level security. And there's a number of startups working on it, but it's not quite there yet. Okay, thank you very much.